Hello and welcome to another episode of Math with Stone. Today we're going to be finding the surface area and volume of prisms. Specifically, triangular prisms and rectangular prisms. And a prism is just a block. It's a building block. It's either a triangular one, a rectangular one, an octagon, or something like that. So we're going to start off with a triangular prism. And it's called a triangular prism because of the obvious. It has a triangle in the front or a triangle in the bottom of the shape. Potentially the triangles on the top and bottom of the shape. And in order to do this, we are going to have to know the area of this triangle that is in the front. And the way I find the area of any triangle is 1/2 base times height. It is important to note that this is the base of the triangle and the height of the triangle, and that is what I'm referring to there, the base of the triangle and the height of the triangle. The base of the triangle is the bottom of the triangle, which we are going to call 6, and the height of the triangle is that dotted line from top to bottom of the triangle, which I am going to call 4. Okay? So we're going to be able to find out the area of that triangle relatively easily. That is going to be area equals 1/2 base times height. That would be the base of 6, 1/2, base of 6, height of 4. And we can multiply the 6 and 4 together first, and we're going to get 1/2 of 24. You can multiply it in any order all at once with your calculator, and 1/2 is really just 0.5. 1/2 of 24 is 12. So the area of the triangle is 12 inches squared, something like that. In order to find the volume of the shape, I am going to need to know what is this longer side here. Because essentially, if we were to stack all of these triangles up, one after another, they would go all the way down until you got to this very far end here. So how far down are they going to go? We're going to call that 10 centimeters. All right, so the volume formula for a prism is as follows. It is going to be the area of the base shape, which the base shape is referring to. Is it a triangle or rectangle or something more obscure like an octagon, times the height of the prism. Now the height of the prism is how far is it going to be stacked. In this case, the height is going to be 10, because if we were to actually turn this up on its side, the triangle would kind of be on the bottom, and then it would be stacked up by 10 high. Okay? So the height is, by definition, what would it be if you were to turn it onto that triangle side, and how high would it be stacked? That's the height of the prism. In this case, 10. Area of the base shape, the area of the base shape we've luckily already found. That's the triangle, the area, which is 12. So we get 12 times the height of the prism. If we stacked it up, it would be 10 centimeters high. So the volume, after you find the area of the triangle, is pretty easy. 12 times 10, 120 centimeters cubed. Because volume is cubed, not squared. Surface area, however, is going to be a little more tedious. In order to find the surface area of any prism, you're looking for every exterior surface. So you need to find the area of every single side of this three-dimensional shape. That would include the triangle in the front, the triangle in the back, this rectangle in the right side right here, this rectangle on this side right here, on the other side, the left side, and the rectangle on the bottom. We need to find the area of every single one of those and add them all together. That's what surface area really is. Okay, so we're going to start with the part we already know. The triangle in the front was 1/2 base times height. We already figured that out, was 12. The triangle in the back, also the same triangle. It's still going to have a base of 6 and a height of 4. So that's also going to be 12. But then we have 3 rectangles that we have to deal with. And we need to find the area of all three of those rectangles as well. Well, the area of all three of those rectangles is going to be somewhat easy because a rectangle is just length times width. Well, the bottom rectangle, that one's pretty easy. We already got 6 times 10. That's going to be an area of 60. 6 times 10 is 60. The area of the other two rectangles is the right side here and the left side, which is like the under part right around here on the back part. So that's going to be not enough information provided to us. We need to know what this part here of the rectangle is, which is actually going to be 5. So that side right there is 5, and that side right there is 5. So those rectangles are 5 by 10 and 5 by 10, and normally the 5 is going to be provided to you. So 5 times 10 is 50, 5 times 10 is 50, and we have all of the sides of this shape now. We got the two triangles, front and back triangle, we got the left rectangle, the right rectangle, and the bottom rectangle. We have to add these all together. So we got 12, 12, 60, 50, and another 50. When we add all of those together, we get 184 centimeters squared because it's surface area. Surface area involves squared, not volume, which involves cubed. Okay? So let's try another problem. This time we're going to do a rectangular prism, though. So rectangular prism, volume is going to be all a little bit easier because the volume involves the area of the base shape, which is a rectangle, and the area of a rectangle is really easy. So let's say that the bottom of this rectangle is, we'll go with 4, and the height looks pretty small. We'll go with 2. And this time, if we were stacking it up, I would like to think of the 2 and 4 as the base shape because it's what's facing me. If I were to stack it up upright, it would kind of be flipped over onto that base rectangle of 2 by 4, like the 2 by 4 of the wood. And then we'll call the height of this shape a 12. Okay, so the area of the base shape would be 2 times 4. Area of base shape would be 2 times 4, which is 8. 2 times 4 is 8. The height of this prism would be the 12. And you can multiply 12 and 8 together, and we get our volume. 12 times 8, and you get your volume. So our volume, don't know why I called it an A there, volume is going to equal 96. And we'll stick with centimeters, so 96 centimeters cubed. All right, so there is a formula for a rectangular prism or cube, and the volume formula is length times width times height, which is really just these three numbers multiplied together, which is what I did. 4 times 2 to get 8, and then times 12 to get my total volume. So volume on a rectangular prism, very, very easy. Surface area, just as tedious as it was before. The surface area, again, is all of the sides added together, every surface, every exterior surface, and there are a lot of rectangles here. Okay, so the surface area will involve the front rectangle, and if we draw the three-dimensional aspect of it, this front rectangle, which is 2 by 4, and the back rectangle, which is also going to be 2 by 4, and we have to draw those. So if we have 2 and 4 here for the front and the back rectangles, those are both going to have an area of 8. 2 times 4 and 2 times 4 both have an area of 8. But we also have the back rectangles, and by back rectangles I really mean like the left and right side. I shouldn't have said back. So left and right side would be a 2 by 12 rectangle. So if we take those, they're a little bit skinnier, 2 by 12 and 2 by 12 rectangles, those are both going to be 24. So we got front and back, left and right side. Now we have the top and bottom. We got this top rectangle up here and the bottom rectangle over here, the one with the 4 and the 12. So we have a 4 by 12 rectangle and a 4 by 12 rectangle. And that we multiply 4 times 12 together and we get 48 and 48. So can't see it, but I'm going to kind of box it for you here. We got these guys, that we have to add together, the 8 and 8, the 24 and 24, and the 48 and 48, which probably added too many rectangles to deal with, but that's okay. So we have to add these two rectangles together, the 8s together, to get 16. We have to add the two other left and right sides together, the 24s together, to get 48. We have to add the top and bottom rectangles together, which were both 48, to get 96. You have to add all of these rectangles together, all of these top, bottom, left, right hand rectangles together, and we add them all together, 96, 48, and 16, you get 160. That is our surface area of this shape, is 160. Again, all you're doing is adding up every single area of the front, back, left, right, top, bottom rectangles that you're provided with. Okay? So it's a tedious task, centimeters squared, but it's not that hard to do. It's just tedious. Don't forget one of them. If you forget one of them, you're going to be very upset. All right? We got one more problem to show you. In this one, we are only going to be finding the volume of this triangular prism. And occasionally, volume problems will be a little problematic with triangular prisms that don't give you all the information, and they will normally provide you with a right triangle. And if they give you a right triangle, they can exclude some information. For instance, in this case, I am going to call this side here a 6, and that side there a 10. And in order to find volume, we need to know the area of this triangle that's the front. In order to find volume, we need to know the area of that base shape. Well, the area of the base shape needs this missing side. It needs the height, not of the prism, but of the triangle. We need the height of that triangle, and we don't have it. So what we need to do is first find the height of that triangle, and we're going to do that with our handy-dandy Pythagorean Theorem, because this is a right triangle. The side across from the 90 degrees is the 10. That is our hypotenuse. That's going to be the C. This 6, I'm going to keep consistent, is the bottom of the triangle. We'll call it bottom is B for 6 and the B squared. Could have also been the A. The height is what we're missing. We're going to call that X, or you can call it A. It depends on your preference. I like to call it X. So we're filled in our Pythagorean theorem. We got our A squared, B squared, C squared, X squared in this case. X squared, 36, 100. Subtract 36 from 100. You get 64. Subtract 36, you get 64. And then we have to square root 64, and the square root of 64 is 8. We now have the height of that triangle. And we now can use the height of that triangle to find the volume, which is the area of the base shape times the height, not of the triangle, but of the prism, which in this case, I'm going to say the height of the prism is 14. So we have the volume of the base shape, we haven't even found that out yet, times the height of the prism. We do have the height of the prism. We can fill that height of the prism in as 14. But the volume needs the height of the base shape, so we need, needs the area of the base shape, so we need to find the area of this triangle, which was the entire reason we had to find that 8 out. So we need to find the area of that triangle. The area of the triangle, and of any triangle, is 1/2 the base of the triangle times the height of the triangle. Base of triangle, height of triangle, not base shape, not height of prism. Base of triangle is the triangle is the 6. I think it was 3 last time. Height of the triangle is going to be 8. Okay, so now we got the base of triangle, height of triangle. Area of any triangle is 1/2 base times height. If you multiply those together, 0.5 times 6 times 8, you get 24, and I multiplied them all together right away. So that is my area of the base shape, which is the area of the triangle. Now we know 24. So it's a lot of little mini problems to actually just eventually just multiply 24 and 14 together, because now we have the area of the base shape, we have the height of the prism. We can just multiply 24 times 14. 24 times 14 is 336. And we'll keep it consistent, and we'll call that centimeters cubed. That is our volume, and that would be our final answer. All right. So again, if you have a right triangle within the prism, you might have to do the Pythagorean theorem first, just to either find out the missing height of the triangle, height of the triangle, or base of the triangle, base of the triangle. You might also have to do it for surface area, just to be able to find out what one of those rectangles is that you're missing. All right. So that's going to do it for today's episode. Till next time, stay thirsty for knowledge, and I will see everybody later. Bye.